Alright, welcome to the Pac-Man problem. Problem number 6. Alright, so problem number 6 is in radians. And it says 17 pi over 12 is how big this arc is, right? Or this angle. Okay? That means that this angle, right, is going to be 7 pi over 12. The reasoning is because it has to be 2 pi, right? And if I think about that, what's 2 times 12? 24. So whatever this is has to add up to 17 to be 24. So 7 plus 17 is 24, right? Okay? So that's how we got this. Because we said that this whole thing is going to be 24 pi over 12, right? Or 2 pi. And if this is 17 pi, then this is 7 pi over 12. But we didn't actually need this. I was mistaken. I thought they wanted us to find this one, this arc, but they don't. They just want us to find this arc. The arc of the Pac-Man. Okay? And to find that arc, we need to find the ratio. But what's awesome with radians, right, is that the ratio is given to you. The ratio is 17 over 12. That's the ratio of the whole, right? So the cool part is that's the ratio. Now we just got to talk about the circumference. The circumference is equal to d pi. We know that this is 9 inches. That means that the diameter is 2 times the radius. The radius is 9, so it's 2 times 9 pi. So it's 18 pi. So the circumference is 18 pi. That's how far it is around the whole circle. But we're only going 17/12 around the circle. So if we're only going 17/12 around the circle, then it's going to be 17/12 of 18 pi. Right? And when we do that, we can use our upside down division and go, hey, what goes into 12 and 18? 6? How many times? That leaves the 17, it leaves the pi, and 6 goes into 18. 3 times, 6 goes into 12. 2 times, not bad. And then, so then what is that, 51 over 2?
What did you get?
Pi over 2, 51 pi over 4. Why is it half?
Why is it black?
It's 17 pi over 12, right? check. 17 pi over 12 would be the same as 17 over 12 pi and 180 over pi, which is 12 goes into 180 15 times, so 15 times 17, right, is 255. Okay, and then divide that by 360, break that down. So we got 5, that's 5 and 1, that's 51. And 5 goes into 36.
7. Are you trying to do like 36 divided by 5?
Yeah. That'd be 7 with 1 and 2. That'd be 72. And then 3 goes into both of those, right? So 3 goes into 51, goes in there, but once with 2 left over, so 7. And then 3 goes into 7 twice with 1 left over, and 3 goes into there 4 times, right? So it's 17/24. Well, that's why. My bad. So the reasoning was I was using the 17/12, but it's not 17/12. That's the ratio it is in pies. But we have to remember that it's 17/24 because there's really 24 pieces. So that's why I was tripping. So this is actually should be times over 2, right? So 18 pi over 2 because there's 2 pieces, or this is actually 17 over 14, or 20. Sorry, 17 over 24. And so when we do the 6, we should say 6 goes into 18, still 3 times, right? But 6 goes into 24, 4 times, right? So then we will come up with 51 over 4, which is what we should come up with. We have to remember that even though this is in pi, it's 17 pi out of 12, but we got to think about when we take it out of pi, we have to think about how many pies there are. So there's 2 pi, there's 24 pi, right? 24, so it's really 17 pieces out of 24 pieces. So when we think about this ratio, this 17 pi over 12, we got to think this is really 17 out of 24 pieces. And that's the ratio we want to use of the whole. And that's why using the radians easy. But see how I checked it with the degrees? And I can always use the degrees because I can say, okay, that's 255 degrees out of 360 degrees, right? Because 360 make a circle. And I break it down and get 17/24, and I was like, oh yeah, duh. This is 17/12 because remember the pi is half a circle. So we're talking about it with respect to half a circle. It's 17 pi 12. So it's 17/12 of half a circle, right? But it's really 17/24 of a whole circle. Does that make sense?
Yeah, we do.
So that's why when you deal with radians, you got to take that bottom and double it. As long as you take that bottom and double it, you're good to go. Now you have your ratio. So if they gave you a ratio of 19/5, then it would be 19/10 is your ratio. Does that make sense? And then you just deal with it from there. Now you can always work backwards too if they want this piece, right? Well, how much would this be? Well, that would be 7/24, right? So then we would take 7. This is gone. Oh, that was close again. Sounded in. I'm gonna
It was
go
close.
again.
It was in.
All right, so 7/24, right? So 7/24, and then that would be of the whole,
Yes.
right? And And the hole is 18 pi. The circumference is 18 pi in this case. Right?
Yep.
And then we think about, well, what goes into 18 and 24?
Oh, 6.
6? So 6 goes into 18,
30.
and 6 goes into 24. So we got 21 pi over 4. That's how long this curve is. Okay, that's the distance of the short Pac-Man curve. Yes, ma'am.
Where do you get the 18? Or like
Oh,
that
the
big?
18 came from the diameter, the circumference. I'm sorry. So the circumference is d pi, the diameter times pi, and then the radius is 9. So the diameter is 2 of the radius, right? So it's just 2 times 9, which is 18.
Oh.
Okay? So that's how you have to come up with the circumference, and then you take the ratio of the hole. The ratio of the hole, that's it. That's all it is. Okay? And that's why using radians, we use the radius a lot when dealing with arc lengths. Okay? Alright. And there's an actual formula in there, but I don't like to teach the formula. I just like to teach how to do it. You see what I'm saying? I can teach you a formula, but then you have to remember a formula. In this case, all you have to remember, oh, it's of a hole. If I always remember that a circle is 2 pi, right, then everything else becomes easy. Okay? I have to just remember what the hole is, and then this is the ratio of the hole. So if it's 255 degrees, then it's 255 out of 360, because 360 is a hole. Does that make sense?
Oh, yeah.
Okay? And then this one's 17 pi over 12, but that's out of 2 pi over 24, right? So 24 pi over 12 would give you 2 pi, right? So that's out of 24. So you have to think of it like that. It's really 17 out of 24 pieces. It's always twice of these. Because that's always thinking of a half circle, right? So this is always with respect to a half circle. So a whole circle would be 2 of those diameters. So that's how you deal with the radians, and how you deal with the degrees. Just throw it over 360. Okay? And it's all about ratios and percentages.